My name is Łukasz Langa.
And my name is Paulo Galindo.
And this is the Core.py podcast, a new podcast where we discuss internals of CPYTHON and our adventures in making a new version of your favorite programming language. Today, we're bringing our close friend on the podcast, Yury Selivanov. He is a Python core developer, a PSF fellow, and the co-founder of Gel, formerly known as EdgeDB. Hello, Yury.
Hey, good to be here. Thank you for inviting me.
We need to address something before anything. Łukasz, you said we are a new podcast. Did you copy paste the? Did you copy paste the?
Yes.
The thing from the old podcast? We are an established podcast.
No,
I know
okay.
it because every single time I start, I struggle to say established because it's a fucking weird word. And then you say a new podcast, like this dude can do it, and I cannot.
Redshifted podcast.
Yes.
We're doing this so rarely these days that it feels new every time.
Yes, at this stage, totally new. We should do like Yury and just rename the podcast. Like just say, okay, it's time to call it the Gel podcast or the Jelly podcast.
Oh, by the way, is it pronounced
that
gel
Ruby.
or gel? Like, is there a j? Or
How it's pronounced? Yeah.
Just like GIF and GIF.
We have a smart one here. Eh? Can I say hell? That's how we
Hell?
say in Spanish.
I can say hell.
Hell.
Hell?
Yes.
Yeah, that's right.
Very good. Yury, okay. What do other podcasts fail to touch that you would like to talk about? That's the first question. Normally it's the last one because like you ask a bunch of like boring questions and then you say, do my job. Tell me what I should have asked you, right? And then, people think this is smart because they say, wow, what a good question. I'm sure nobody's doing the same shit. But we are doing things the other way. So what do you want us to ask? Yury? Like,
This is a profoundly deep question. No, like, who does this to a guest? Like, what kind of podcast are you?
we are professionals, dude. We are professionals.
Like, you're asking me to do your job.
Yes,
like
exactly,
right now.
exactly.
Just
How do you feel as a company founder that someone is asking you to do their job? Maybe that should be the question, eh?
yeah, fire them. Anyway.
So it's fine.
Anyway, I think that usually when I go to podcasts, it's mostly about like, tell us more about Gel, tell us more about company, or tell us more about how to become core developer. But rarely someone asks me what actually drives me to do any of those things. Like, why? Why am I doing it? Am I a core developer for money or just to write some Python code, or like what drives me? And I think that's actually an interesting question that I haven't answered probably ever.
Yeah, that's actually a good question because you are very prolific.
Probably used to be.
Like there's a lot of whys here to answer. Let's start with core developer. Why core developer, Yury?
So I can answer why core developer slightly later, but I can start with that. What drives programming in me generally, and actually that's why I sort of stepped on this path of becoming core developer, and this is why I started my company and all of that stuff, is that I don't like friction. I don't like bad APIs. I don't like things that should be easy but are not easy. I want to fix them, and I have like urge to fix them. If I see something inefficient, I have an urge to fix it. If I have something weird, I have an urge to correct it and make it not weird. And that started with CPython. Like literally, my first email was about fixing hasUtter function in Python 3 because it was sort of broken. Like it basically silenced all errors. Like if you have custom getUtter function that raised, I don't know, 0 division error, hasUtter would just say, hey, no, you don't have this property without propagating that error. And if you're programming like an ORM or something like that, where you have like lots of dynamic stuff and your exceptions are hidden, they become nightmare to debug. So that was like literally my first contribution ever, to just like go to the mailing list and ask why. And that question was asked multiple times, and Guido usually said, no, like we're not changing this behavior, but Python 3 was such a big shift that, sure, we can fix this bug. And it just continued throughout my career, like messing with databases, because I don't understand, like, why do they have to suck? There's no reason for that at all for them to suck, but it's treated like a law of universe that they have to.
Right.
I want to challenge that. And same like throughout my career, like this is what actually driving me to do things.
How do you select? Like, for instance, I'm pretty sure you can basically spend your whole life fixing shit on the database realm and the CPython. I mean, certainly CPython is a never-ending source of things to fix, let's say it that way. But how do you select which ones?
I think in some almost like perverse way, I'm drawn to things that you are not supposed to be fixing.
like another. What will cause the biggest pain?
No, like literally, the
pain-driven development.
Just like trying to come up with like a new query language. You typically probably don't want to do this. Like there are more productive, I don't know, like faster ways to become rich or faster ways to get instant gratification than this. Or like my async await work. Like it's not something that you just like go and do usually just build stuff with it. But for me, it's like, okay, I want to fix this, and like nobody probably is thinking about that, and this is how I get like my high. This is like how I get, I don't know, how I can enjoy things is by doing things that most people think, hey, like probably just why would you even change this? Like this is the norm. And for me, that's what drives me.
That's such an interesting answer, to be honest, because like normally, I mean, nothing wrong with the classic answers, right? Like I think I'm one of the ones that give this answer, but normally when people answer this question, they are always driven by external forces. So in the sense that, oh, you know, like it's just to make a change in the world and like to improve this and that. But like, I think you're the first one who, I mean, I'm not going to say that you're just like looking at yourself, right? But the first one that is driven by internal forces. You're just saying like, okay.
No, I mean, obviously, I have external pressure as well, and obviously, like I became Python core developer because I was using Python to build something for myself and my previous company and all of that stuff. But that is sort of that's the routine. That's the routine of building stuff and I don't know, like delivering stuff, shipping stuff. This is the routine that you just live with. The question is, how do you get like this extra kick? How do you enjoy it even more? And this is usually by trying to just look at something that you yourself don't know if it's possible to solve this or not. Like just like, let me just try to attack this thing and try to push it through the roof and see where I end up.
Right.
And most often you like I sort of have an idea where I can where I can get with this, and I don't get there, but I get somewhere in the middle, which is already pretty interesting vantage point sometimes, and you can see other things. So I think it's just like my mode of exploring things and thinking about things like, why is this way?
Right.
Does it have to be this way? Can we make it better? Can we make it different? This is the framework. It's hard to always do this. I wish like I was like, I don't know, like a billionaire and I could just do this all day. But I had a few moments in my life where I sort of started doing that and ultimately received a lot of sort of I don't know, just joy. Yeah.
Do you find yourself sustaining? Like, is this something that just gives you joy by itself and you don't need anything else? Like, it's just finding these things and fixing the things enough to just justify all the effort and whatnot?
Yeah, I don't know. I was actually recently diagnosed with ADHD, and with people that have ADHD, you have this hyperfocus thing when you can just focus obsessively on something.
Right.
And I think this is ultimately like it's just like the way my brain is wired, because when you're working on something hard, and it takes time to do it, right? You can become this hyper-focused person. And when you're hyper-focused, it's like you basically ignore everything around you. You just want to deal with this thing and nothing else. And you can work with it like nonstop. You can sacrifice food. You can sacrifice sleep. You can sacrifice all extra thoughts.
Right.
And you just basically think about this thing. You dream about this thing in your sleep. You do all of that. So I think like now that I'm thinking about and answering this question, I think that basically like my biology basically like shaped me for being this way, because like I get enjoyment when I'm hyper focused, because like when I'm hyper focused, I'm super productive. When I get a kick out of it, and doing challenging things just keeps me in that flow state longer. After that, I have usually a burnout and whatnot. It's not pretty.
Right. The consequences.
Exactly, there are consequences to it. Yes, but when I am in this hyper focus mode, I enjoy it.
Right. Before we get to like practical topics with your actual contributions and your actual work, let's talk about something controversial just to start with, so that people can have something to like help them with their coffee in the morning. So I know that you like Rust. There is a lot of Rust code in Gel, and there's going to be more, I guess, right? Like, it is constantly being made faster with Rust and so on and so on. So you working with that language, what about it do you miss in Python? What are the things in Rust that you wish Python also could have?
Probably gonna say some offensive things now.
Yes.
Yes.
Offensive. One of us.
But no, I'm not writing Rust code myself. Like, I'm just looking at it from the distance, and from the distance it looks
like you go to an art gallery. It's like, oh.
Yes, exactly. Like, I'm feeling smart when I'm staying next to Rust.
This makes me feel.
I'm not actually writing that much of it myself. I know the language. I've written some code of it, but it's not nowhere near close to the amount of the code that I wrote in Python. Or
you can say that you consume Rust code.
Yeah, I consume that. I like the ideas of it a lot. I like the speed. I like that the code runs fast, and I like that this is not just speed. That there are some things that can actually make it better. Can make you better at reasoning about the code complexity. Like this whole spiel about fearless concurrency. This is great. The whole spiel about memory management. This is great. That you can write memory safe application. If it compiles and if you use borrow checker and like nothing else, you know that, hey, like your code is good. And I think Rust programming language probably is one of the first languages that almost sort of like did it at scale, right? Like there were specialized programming languages and specialized compilers and specialized tooling that people probably used for this, but it was never mainstream. And Rust made this mainstream.
Right.
And this is what I like about it, is that it's sort of flipped on its head what a programming language can do. It's not just about programming something, it's also about giving you guardrails and giving you confidence that it works beyond just the type safety. But speaking of type safety, I never had time to actually just invest myself and get really productive and really good at Rust. And that's why I'm going to talk about TypeScript.
Oh,
I'm kidding.
What a turn!
I think that Rust is very complex. It's a new programming language, well, compared to Python anyway. Younger programming language, and I don't think that too many things from Rust can be ported to Python. Maybe macro system, in a way. This is what I think could be cool for Python. Obviously, it would be abused and whatnot.
Mark Shannon proposed it.
Yeah. Like I'd be supporting macro system for Python.
It was called hygienic macros. I think.
Yeah. So this is what I would personally love to see, even though I know it's going to be abused to hell, even though I know that many libraries and APIs will become totally unusable because of that.
Man, but that's going to be hell.
Even though I don't like this feature in Rust specifically because sometimes you don't know what's even going on anymore. Like you import something and the spooky action at a distance and things can happen.
But you think it would be abused? In Python, there are plenty of things that you could like look at them and you're like, oh, operator overloading. Like clearly people are going to make crazy things with it. Or, oh, you can make encodings that are crazy and do whatever to your source files. And, oh, you have the import system that is pluggable. Oh, you can do descriptors and a bunch of other things. And like, yet, do people really abuse it? Like, what do you think?
Yes. I mean, okay, I can guess. Yury, you are the guest. What do you think? It doesn't matter what I think.
I do think that people abuse it here and there, but overall, the popular packages are fine to follow, and usually they use it to their advantage. With macro, though, it's might be slightly different. I think it's
no, man, like no. I'm super opposed to like I cannot believe you're okay with this, both of you. Like what is this? Like no, man, people will abuse it to hell, and it's worse because this will be side effects at parse time. Can you imagine at parse time, dude? Like that would be insane. Like what is available at parse time? Who the fuck knows? Imagine that someone installs a PTH file at parse time. Like parsing is not safe anymore. Like, well, I mean, it's not safe now.
I'm just thinking maybe I can drive Pablo further and saying we can implement this macro system inside the tokenizer, Pablo.
I mean, you are saying it almost as a joke, but like if you pull that thread, you will see that thing is very close to what you just said. No, dude, like man, we had entire outages because we are just fucking importing like OpenSSL too soon because like both of three. some small library. Nobody uses that, right? So those guys are monkey patching shit to their advantage, as you would say, Yury, to their advantage. And then because we import their monkey patch thing, it doesn't work. So imagine now that it happens at parse time.
Yeah.
What the hell? Okay, I have a question.
No.
TypeScript.
We never came back to TypeScript.
Yeah.
No, but I have something before and it's going to dilute and it's a fucking good point. Okay, listen to me, Yury.
Okay.
You said that Rust is this cozy thing that has you at night and makes you warm and it's so beautiful to look at. But don't you think that is dangerous? Because like people think like, oh, I'm protected by this language. But then they look below and there is glibc. glibc and their non-thread safe primitives. Did you have anything to say about that, Yury? Some story to share, maybe?
Oh yeah. We just had a story about this. We wrote a blog post.
Okay, tell us about that.
Matt Mastracci and Michael Sullivan. Sully works on MyPyC, so that's how Python people might know him. And Matt is he's incredibly good at Rust. Anyway, they were debugging a CI failure that only happened on ARM64. And long story short, there is a blog post about this. The blog post made to top of Hacker News and was there for quite some time. Also, it was on top of our Rust and our programming on Reddit. So it's a good blog post. I actually recommend you guys reading it. But the culprit of that thing was that OpenSSL when imported was messing with environment variables and like OS environment variables. And we were not using anything. There was a Python exception being raised from, socket module. That Python exception basically under the hood within CPython internals was preparing the error message for the exception. That error message used getText to get the translation for it. GetText looked at the environment to get the current language or locale, whatever, and crashed because apparently setenv, getenv, they're not thread safe at all.
Fucking, it's always a mistake, man. Like sending the error crashes.
It's multiple layers and all of our favorite actors, OpenSSL, of course, POSIX, Python, and safe Rust. Essentially, all of them intersected in one focal point, and then the crash was like pretty hard to actually debug.
Right.
It's an interesting detective story, but yeah,
they did it right. They debugged it. It was amazing.
Yeah, we did.
They are heroes.
Yeah, but the fun thing about this is that like the Python there is incidental, right? Like you could just clearly have the same issue with just Rust that calls into any environment getting and setting.
It makes it extremely annoying, right? But now you need to jump into the interpreter. Yeah. But like you say, like, oh yeah, they debug it, like any Wednesday. But no, man, dude, like that, like everyone go and read that blog post. It's amazing. They were like just looking at the assembly like it's a newspaper or some shit, and they were like, oh yeah, I used to work on compilers, but like I don't remember this assembly, but I know that this control flow graph, blah blah blah. It's like, what do you mean? Like, no, and this is not even x86 that you can say, well, I know it's ARM64 or some shit, right? Like it only happened on ARM.
It's pretty good. I played my tiny role of being a Python expert. I think at some point I put them on the right way, explaining, hey, like this is probably what happened here, and then they were back on track.
Nice,
but they would figure it out without me easily.
Fantastic blog post. Yes,
it's a good blog post. Anyway, back to macro. People would abuse them. What excites me about macros is that not people will abuse them. It's that I will abuse them.
Right.
So this is why I'd be excited about having macro.
Masks are off.
The world will be hell. Yes.
So all of this introduction, I'm just dreaming to problem. No, you just want to solve your stuff with macros.
Anyway, so Rust is like this new thing. It's pretty fundamental sort of departure, I guess, in terms of what you can typically do with programming languages. So this is cool. This is why we, I guess, all like it. Even those like I, who are basically on sidelines of Rust being used. In any case, TypeScript, I think, is much closer to Python than Rust is. And my main sort of pain point now with Python is just the typing. I want typing to be closer to what TypeScript can do.
I see.
In capabilities. And this is my biggest wish for Python now.
But in what sense?
Macro is like one of those things that probably will never happen, or at least it's not on the horizon. This is how I would put it. But typing, for example, that stuff can potentially be improved. And I hope that either we internally with like a gel with Sully will have a PEP eventually, or somebody else maybe will do it. But this is the next chapter for Python for sure, and that will enable a lot of interesting things with Python.
Yeah, because you can run Doom on TypeScript types.
That's another insane
but
thing.
You cannot run Doom on Python types, which like is just sad.
mean, you totally can. They have side effects.
You can't even run tic-tac-toe.
So in general, you're like team typing, but in particular, you're not happy about the state of typing in
yes,
Python.
and I have to clarify what exactly I mean. Like, what exactly do I actually want from Python typing? And what I want, I basically want programmatic types. When you can construct a type out of type programmatically. When you can say, hey, like this generic depends on that generic, but it will look into that generic's properties, for example, and extract all of properties that start with letter A. Like this kind of stuff. Because that kind of stuff allows you to do interesting things. Like, for example, you can generate a query builder for our database or like strictly type SQL Alchemy, so that in your IDE you just construct a query with SQL Alchemy and boom, you have the type for it automatically. Like the return type of that query that you just constructed is fully figured out for you and fully resolved. That is the kind of magic that is, well, it's not easy in TypeScript, but it's doable.
It's doable.
And in Python, it's completely out of reach. So like my own like personal pain point right now is that the kind of support that we have for TypeScript is just unimplementable in Python. And this just rubs me so wrong, because I think that that Python can totally do this and should totally do this. And then it will be the greatest language on earth.
Very cool. All right. Yeah, very motivating, especially that like I have similar thoughts about the Python type system. I'm still like missing intersections, which there is a proposal brewing, but like it's been a long while. Like I would like it to definitely allow us to build types from other types and to have intersections, and then you actually have the full grammar that allows you to do interesting things.
And then we can run Doom.
Yes, then you can, yes.
Okay.
Right. So your claim to fame is actually not typing related at all, right? Like within core Python, everybody knows you from your work around async await, asynchronous comprehensions, and asynchronous generators. And recently, asyncio task groups. So let's talk about this for a second. Like some people definitely only listen to this episode, like, you know, to learn more about asyncio and everything. So where did your interest in async programming come from? Because for whatever reason, I like it, and a ton of other Eastern Europeans like it. For whatever, I don't know how that works.
It's true.
Our brains work with async programming, so I want to hear from you, Yury. Like, why do you like it? Like, why do you think it's a good thing to write programs where functions have callers?
First of all, you should have muted the asynchronous generators. Like, put that little beep.
It's the best feature, no? It's so easy to implement.
Yeah, exactly.
You were not crying in the floor for some leak or something, right? No, that never happened.
Completely safe.
I mean, just one parenthesis, man. I just find this always like fantastic, because like we know what we're talking about, because we know how insane synchronous generators are. But like one thing I constantly remember by our listeners and by talking to random people is like these things seem arbitrary. Like we say like, oh, you know, coroutines. Oh, that sounds complicated. Synchronous generators. That sounds like the same thing. No, it's much worse. But only we know about it. Like we protect the knowledge. You know.
I still remember us talking to Brandt when he showed us a picture of this whiteboard, and it sort of reminded me of this picture from Beautiful Mind, of completely crazy person drawing on the wall, and Brandt was like this,
with all the threads, yes,
trying to just decipher how asynchronous generators actually work.
Yeah, but that is your code.
Yeah, it's mine.
It's not like, oh, he was trying to decipher how it worked, like, you know, like God came from the heavens and like gave us a synchronous generator. No, it was you. You gave us a synchronous generator.
Yeah, that's true. Let's talk about asynchronous generators, but maybe let's start with async await and let's get back to them, because
yes.
I think we can sort of explain a little bit of how they work to people, just to understand like the actual complexity, like why asynchronous generators are so complex that someone as bright as Brandt had to spend a couple of days at whiteboard
Crying.
crying, maybe crying. Anyway, async await. So it all started with Google.
What?
It all started with Google Wave.
Yeah?
What?
If you remember when they presented Google Wave, that was like a while ago. Like just like we had Gmail and I think we had Google Maps, but the world was very different.
Oh, yes, of course.
And then they showed this. They had this Google Wave demo, and that Google Wave demo was just completely mind blowing to me. I think it was like 2010.
Yeah, something like that. Web 2.0.
Yeah. All that stuff. And in that demo, they showed. Like this completely mind-blowing thing, like someone typing somewhere and that text immediately shows on your screen, just like in real time without clicking the button. Because previously all of the interaction with services and web, like Ajax and Web 2.0 and like all that stuff, you click a button, then something happens.
Yeah.
But when you just type and something happens, that was actually mind-blowing. And it's like, it's fine when you type and something happens on your machine. In this case, it was someone typing somewhere else. And that was instantly shown on your screen. Like, that was cool. And they were just like hitting backspace and like removing stuff. And it was like, basically, they were showing like the multi-editing capability, like oh, pretty normal and wouldn't shock anyone today. But back then, for me, it was just completely mind-blowing. That this is even possible, and I started searching like how did they do it, and apparently, they used Java, and they used the asynchronous non-blocking framework, non-blocking IO to do this, and this is how I started looking at Python asynchronous IO. And back then there were two major options, well maybe three if we count Tornado, but it was Gevent and Twisted.
Yeah.
And Twisted was too twisted for me. Like I looked at it and I can't comprehend this. This is too big for me to fit in my brain. And also Twisted was really heavy on callbacks and transports and protocols and kind of like forcing this callback heavy code. They had a generator-like thing where you used yield instead of await, but I don't think it was like widespreadly used. Like if you open...
No, it wasn't at the time. No.
Exactly. Like if you open the Twisted documentation, just like looked for it, you would never notice it. It was mostly about callback and...
deferred.
Yeah, exactly. And I just didn't like it at all because I knew that, hey, this is going to be spaghetti code. If I use this, I will be hating myself for using it. And that was Gevent, and I looked at Gevent, and
and it was magical, right? You didn't have to change any code.
Exactly. It was magical, but I think it was a little bit too magical for me in a way that, like this is also not super cool. So anyway, and hard to debug, and like all of the obvious issues that are coming from using Gevent.
And it breaks a new version of Python. Yeah.
That sort of happened, and then randomly I actually saw, I think it was Mozilla BuildBot source code. I were debugging some of it, like why it's not working for us, and I looked at it and oh my god, this is interesting. And that was actually Twisted code, but it had those yields in it. So I discovered that Twisted can do this, and that was an aha moment. Like, okay, like having those yields instead of callbacks and instead of implicit magic of Gevent, this is actually cool. Like this is, and I was curious also how it's even implemented. Like how does it work? And this is the first time when I familiarized myself with generators, and it took me a couple of days of just playing with them to understand what's even going on. Like how can you send something in a generator and then it resumes? It's completely alien to me, and it took me like literally a couple of days. Like I was not like bright enough to just get the concept.
Right.
I played with it for a couple of days to understand what's going on, and after that I realized that hey, like I don't want to use Twisted. I'll do the next best thing. I will build my own, which obviously is a stupid decision, but I think it helped me a lot because I started building my own, and I started building it with this generators as a first class feature. Essentially, the framework was called Spin, And Ellis, my co-founder, and I built a lot of software based on that framework. I spent years in just building it, refining it. And then asyncio started happening. Back then it was called Tulip.
Yeah.
Guido was working on it. A few other people were working on it. And Tulip at that time, or asyncio now, they basically, they also use generators, but they use this new thing, which was called yield from, which is like a higher level abstraction on top of generators. And basically, by using yield from, you can remove a lot of complexity of your internal sort of framework logic to drive those coroutines to execute the code. You just remove it. You can basically tell, hey, CPython, do it for me. I don't want to do it in my Python code. That's much faster.
Yes.
So, but I was torn. So basically, like, we have this yield from thing, but it's two keywords. We have yield, and yield is just one. Like, it just didn't feel to me right. And this is how I realized, hey, C# doesn't have yield from. They have await. How about we maybe rebrand yield from into await? Is that even possible? But then there was another sort of thing that actually helped to advance this to a stage where I could just go and like talk to Guido, for example, about this idea. It's that we need to build more. Like, if we just have async and await, it's not enough. Sure, like you can await on a call, beautiful, but Python has other sort of things on top of function calls. Like Python, for example, has context manager protocols. You can say with file, with open, or with something else. Python has iterator protocols, so you can iterate through things.
Right.
Like, and back then I was also like, I was not building HDB or Gel, but I was building what was the predecessor of that technology, essentially.
Right.
And with databases, you have a direct use case for this. So suppose you have your database library. It's a network library, right? So it's natural for this library to have async and await in it. But now you want to open a transaction. So how do you do it in Python? In regular Python, you say with db.transaction or something like that, and it opens the transaction for you. Easy, convenient, nice.
Right.
How do you do it with async await or yield from? Well, you basically say, I don't know, transaction equals yield from db.transaction, and then try and finally and accept, and you handle those cases. So basically, the composability around the syntax and around the query language was broken with yield from. And it became clear to me that, hey, like, it's not enough to just add async await. We have to enable it for other things, like for loops, for example.
Right.
Because with databases, you can, well, it's not as widespread as it used to be, but with databases, you can open a cursor and it's like a constant connection to your database, and then you can prefetch things. Like, you can start iterating through rows in your database, and it just literally goes on wire to the database, fetches the next row, give it to you, and so forth.
Yeah.
And we also want to have asynchronous iteration then. And this is when it clicked. Then, hey, like, what we should do, we should actually make async await like first-class citizen in grammar and in Python. And basically, we have to have asynchronous context managers. We have to have asynchronous iterators. We have to have more concise, short syntax for coroutines.
And that's amazing, since like today, when you're using HDPX in the asynchronous mode, like all your writing is asynchronous context managers, like async with, like, is like all the way down, right? Like, it's exactly the entire composition of it is just that. Like, all the example code that I show to people with this is just full of those context managers. So yeah, great call.
Yeah. If you want to talk meta, maybe towards the end of this, we can talk about composability in general, because I think it's like one of the things that are usually glanced over when in computer science in general, programming languages, in libraries, in frameworks. I think people don't pay enough attention to composability, and this is why we end up with having bad libraries where we have incomposable APIs or APIs that poorly compose, or we have bad languages like SQL, for example, which I can say that.
That's true.
This may be an interesting topic to discuss, because like in asyncio in particular, I mean, we have this is in your face, right? Because the two-color problem and all that stuff, like that is an interesting conversation around how you compose this with existing code and whatnot.
Yeah.
But I wanted to say also, like, it was not easy because you're saying, oh, we just need to add await and all this, like, asynchronous, but it was quite a journey, right? Like, it was certainly not easy.
Yeah.
Tell us a bit how was to add async and await as keywords. Like, how do you approach this? Okay, you want to introduce into CPython, but now you need to change half the language, right? Because you need to change the tokenizer and the parser and the compiler. Like, so how was that?
It was basically like a sprint. So first of all, I came to Language Summit, met with Guido, maybe first time in my life, personally, face to face. And I basically just showed him like a page of a proposal, just what async await could look like. He just immediately liked it.
Oh,
he's like, okay, like
interesting.
Yeah, he was like instant sell to Guido, and he's like, yeah, like let's explore. We need to prototype this. So I think I don't remember like the exact dates, what was when, but I remember that I started hacking right at the conference. So basically on Sunday morning, while the conference was still going, PyCon US usually ends on Sunday. But I was basically hacking like from 8 a.m. till the moment I left the conference. And then that specific PyCon was in Montreal, Canada. And I took a train to Toronto where I lived.
Yeah.
So I was hacking on the train. And then I just straight from the train station went to my office and just continued hacking nonstop for like 24 hours.
So talking about focus mode and obsessing and whatnot.
Yeah, exactly. Like this is the kind of obsessive thing that I have sometimes, and when it's triggered,
you hack so much that for a long time to check if the function is asynchronous, we have this structure member in the tokenizer called async hacks.
Yes.
That you added. And tell us about what async has to do. Like,
and I don't remember that anymore.
Well, I will tell you what it does because
my brain is protective and they just erased it.
No. You will suffer. You will suffer now. I will tell you because I just killed it and it was not easy. Let me tell you about what it does. So just as a small parenthesis. So normally the tokenizer does this beautiful thing when it just creates this token thing, right? And like the words stop meaning anything. It's just now a number. It's 6. And the token is await or async or for or what the fuck or whatever it is, right? And then the parser goes and says like, oh, like now I have these tokens and like this, you put this token with this token, now is this structure and I will create the AST. That's how things are supposed to work, Yury. But then what can happen if you introduce this concept of async hacks? What is the tokenizer just looks a bit and it's like, oh, can I see the A? Okay, an A, interesting. What about an S? Oh, hash. Okay. What about async? Okay. Is that async or what is following? Let me look. And then it looks if the next thing is def. And then it says, okay, this is the keyword. That's illegal. The tokenizer shouldn't do this. But then you store that in the variable called async hacks. And async hacks equal 1 mean that the function will eventually become an asynchronous function because it's async def. But those are 2 tokens, right? It's not 1 token, it's 2 tokens. So yes, I know your secrets.
For what it's worth, I think the hack was beautiful. Not the implementation. Like async hacks, for example, is a horrible variable name. I don't know what I was thinking about. Probably I was frustrated. But I think the idea was beautiful because we introduced async and await, 2 new keywords essentially. Last moment before, I think it was 3.5?
3.5, yes.
Python 3.5?
3.5, yeah.
Like last moment before the feature freeze essentially.
Yes.
Soft keywords actually, no?
Before the PEG parser.
And yes, and they were the first soft keywords for Python.
Yes, but we don't use async peg, right? Like, hacks, peg hacks, like last time I saw.
Basically,
right?
like in my mind, async hacks was full equivalent of your work on PEG parser, Pablo.
Our friendship is in danger. What do you mean? No, disgusting.
But it was practicality that beats purity because in 3.7 this went away, and you know how hard it was for many companies to upgrade to Python 3.7 because they had files that were called async.py.
Exactly.
And they had arguments in function called async equals false.
Yes.
And now like you couldn't upgrade to Python 3.7 because it wasn't soft keyword anymore. It's like it was a lot of unnecessary work. And then PEG parser came and said, said, you know what, soft keywords are actually not that bad.
Of course, they're not that bad, but you should implement it with grace and like beautiful algorithms that actually do something. But like not with like, oh, let me bypass the parser just to look at what the fucking next token is. Oh, it's how many? Okay, and you're saying this like, oh, but Pablo, like you need to be pragmatic and whatnot. This certainly wouldn't like become a nest for like weird bugs. And Yury knows. I like to remember this story. I have remembered him this story about 6 times. But what was the first PR that you reviewed from me? John Pablo. What was the bug? Do you remember?
The GIL removal?
It was this segfault. Yes, it was this segfault that you did async. And then you add this continuation slash, like, you know, the backlash to continue it. And then you put 300 continuation slashes, one in every line. And then you say def, then it's segfault.
Oh.
Yes, because your async hacks was not looking far enough. Just because you have a fixed buffer.
So all this production code that did 300 backslashes was not working.
Yes, it was not working. And then I did this weird like hack over the hack because it was not properly solved. I just fixed the bug, but like not elegantly. You know, John Pablo. My standards were low. And then Yury, this is what I remember him quite a lot. And then Yury like approved the PR and says, "This is good enough." And I remember feeling at the time, wow, I am good enough. But now it's disgusting. I kill my own fix.
But it is also fascinating to me how, like, for whatever reason, PyCon US went to Montreal for 2 years, right? Which is not even US, actually. But that might have had, like, a non-trivial input into the creation of async and await in Python, since you could just take a train and go there. So it actually made it easier for you to be part of PyCon because it was close to you.
That's true, but it also wasn't my first PyCon. I think my first PyCon was in Atlanta, which was
my first was after Atlanta.
I think it was prior.
My first one was in Santa Clara.
Oh yeah, I missed that one.
So just to close this section, what was the hardest part? The parser, the compiler, or the runtime?
So this is actually what I wanted to expand on a little bit, because this is like another question that other podcasts don't ask me about.
Oh, okay.
And what I wanted to say is that I'm not, I don't know, like I'm not John Carmack who can just like load, I suppose he can load like millions of lines of code and just like immediately be productive with it. Like I'm not like that. I usually just copy. I look at similar things. Like this is my approach. When I have a completely new code base in front of me, for example, like I fixed the bug in Dino a while ago, and so like completely alien code base to me. I fixed the bug in like a couple of hours, and I think this works because of the actual approach. And the actual approach that I have is to find things, similar looking things in the code base, and start there. Like don't be intimidated by big code base. It doesn't matter. It doesn't matter if it's like 10 billion lines of code in this code base. It doesn't matter because what you're looking for is something very specific. So in the case with Dino, it was like adding some API for their TLS stack and just like find another function that is like in close proximity in the meaning of what you want to add, find how it's implemented, copy and paste. And bang on it until you are done, essentially. And then at the unit test, find out how unit tests are run. Like that's the most important thing. At the unit test, and boom, you're done. You don't need to know how Dino works. You don't need to know how like 99% of it work. Just like look at where a similar function is declared and do that.
Right.
And I did absolutely the same thing with CPython, because when I started hacking on async await in Python, I did not know how CPython interpreter works. Like I knew the basics of it, but I had no idea about the directory structure, layout, the internal C APIs. Well, I have seen them before, but I had no experience with them whatsoever. Okay, like adding async and await. Well, probably it has to do something with syntax. Let's look at how other keywords are implemented. And back then we had this grammar.txt file. Okay, let me just try to add it here and see where it crashes. Okay, I compiled it, it crashed here. Okay, I'm going to fix it there. Now nothing happens. All right, I'll take a look at another keyword. Like I'll just take a look at the with keyword, for example. Just find where it has, where you have this keyword in this folder, like literally in the parser folder. And then you find out, okay, like this is the place where I probably missed. And you just copy and paste and add it for await. And you just keep doing that. And then gradually, boom, you can parse the syntax now. Or for example, I wanted to add async with or async for, and that basically required me hacking on ceval.c file, which is intimidating. It's quite big. It's very low level, obviously. Again, just like look at how other things are implemented. And you want to add dunder a iter method? Well, look at how dunder iter is implemented. You want to add dunder a exit? Look at how a exit is implemented. And basically, I'm good at this kind of stuff, and I think that everybody should like I'm a firm believer that this is how like every software engineer should basically address the unknown. It's not focus on getting big picture, because you will never be able to get it quickly, and doing that might actually frustrate you and might scare you. Instead of just like doing that, just dive head first. Just dive and stop exploring, start copying, start searching, start grabbing through the code base and start hacking. And this is the quickest way of solving any problem, essentially. So I had the first async await working in like literally 36 hours. But
Wow.
Yeah, no eating and sleeping in the meantime, but 36 hours.
No sleeping, but junk food.
Okay, at the cost of your muscle mass. And
But obviously it was riddled with bug. It barely worked, but I was able to like have like a simple program that had async with, async for, and async await.
Hyperfocus.
But again, like I didn't know the code base. The only reason why I could do this is because like I'm no shy of just looking at the existing code, copy pasting it, and banging it until it compiles and eventually runs and that kind of stuff. And then after that process, like after a week on hacking async await, straightening the implementation and test, by the end of this week, I had pretty good understanding of what's going on in CPython, its architecture, its internal APIs. Not all of them, just the ones that I used, but I figured out how it works.
No, but that's very impressive.
And then obviously, like after a couple of months, I knew pretty much. Well, CPython was simpler back then.
I agree with you in general, and like it's a great way to familiarize yourself with a new code base. CPython being a great example of this. But you're being a little too humble there, because there was no sync hacks that you could be copying async hacks from. So like there was some original work there that like was unprecedented in Python. You had like many of those things that you introduced concepts to Python that were just nowhere to be copied from. So, you know, kind of there's a lot of original work.
But they still built, maybe the async hacks hack was a hack. But the rest of it, it's like it still builds on the same foundation. Like
no, I'm with Lucas. Lucas. Like, and especially I focus on the async hacks because it's
just funny and it's a good name. Yes,
I kill it that one. But like, let's be clear here. Like, just having the concept of like now every function can be two things, right? And teaching the parser and the tokenizer about that is highly non-trivial, especially by the super constrained parser and tokenizer.
I disagree because we had generators. It's the same thing.
Yeah, sure, but like it's not like I just copy paste. No, man, like give you like some pat in the back. You know, like that is cool. Like and I remember actually that you mentioned that you were having trouble precisely with this concept, and you were talking with Guido about ideas about having these two paths from the tokenizer, like that was propagating if a function is asynchronous, because like now you cannot have, for instance, you cannot have a wait on a non-asynchronous function, right? So you need to propagate this in places.
Yes.
So it's not trivial. I mean, we don't need to go there and how it's done, but like it is not trivial. And this is not the first time also you have dealt with this introducing new concepts to a language. So I think this is still impressive.
What I want to focus here on, and like I'm about to be done with this, is that yeah, of course, like, there was some non-trivial work there and whatnot. Like I am a senior engineer after all. Like
senior engineer.
I know my ways around. But what I'm saying is that's just a pattern in my career throughout the career. Is just like not be afraid of big projects, not be afraid of big code bases, even if you don't understand how they work. Start exploring, start hacking. Like this is rule number one that I think everybody should follow, because people just get scared often. I see that. I saw that multiple times when people are just scared of like diving in and fixing and debugging, and instead just ask Google and Google return nothing, and then okay, like it's game over. I'll work on something else. And I think if you resist that, and if you actually go and debug the damn thing and fix it yourself or improve it yourself, then you will actually get good, and you will probably get with LLMs and everything else that we have now, and the all code assist tools. if you have the skill, you'll be able to be like 100x engineer. Forget about 10x, because now you have this power of like a thing that can go and do this digging for you, help you with this digging for you. So I think it's the most important skill, and the skill can be summarized. It's just don't be afraid.
So definitely since Python 3.5, when async await were introduced to today, there's plenty of experience that you gained both as a programmer, but also like as a computer scientist who designs and architects things. So given that experience that you have now, looking back on asyncio in 2025, what do you perceive as the biggest hits of that design, and what you see as the biggest misses of it? And like, do you have any ideas how you would design it differently if you were to start over today?
Obviously, it's async hacks.
Whatever you do, you will be remembered by this. In your tombstone, it will say "creator of async hacks."
So I did not create asyncio. It was Guido, and I think one thing that I think negatively influenced asyncio a little bit, maybe, was actually Twisted, with its heavy focus on futures, deferreds, and protocols, and all of that stuff. That stuff is beautiful, but that stuff basically is too low level. To Guido's defense, we didn't have async await when they started, and async await wouldn't happen without Guido's asyncio. It's just a given, right? And again, to Guido's credit, he specifically was designing async around yield from. But I think that it took us a lot of time to realize that yield from / async await is the right way to compose things. Like protocols and transport and all of that stuff, that can be low-level machinery that mortals should never even see. That the actual proper composability primitive should be async await. And we got there eventually, actually with the help of David Beasley and Nathaniel Smith, because both of them they saw it earlier than me, for example. And I think at that point, Guido wasn't that involved with asyncio anyway. So it was mostly on me to see those things, and it took me a while to recognize them, that they are right, essentially. And I don't think that anything could be different here. I think Guido just did an amazing thing with async early on. But I sort of wish that somehow something would happen that led us to making APIs more centered around yield from / future async await earlier than what we did. I think we just lose less cycles, kind of like in air quotes, less cycles on just iterating on an API design that is just a bad API, essentially, just like outdated old API in the world of async await or even yield from that we had back then. We could have had easier way to sell asyncio to users, to explain asyncio to users, and let them be more productive with asyncio if that was the main focus. And one more thing is that maybe Greg Uvik was right. In his, he had a competing PEP, and it's not so much about syntax. Syntax doesn't matter. He had different syntax for async await, co-call, I think, and co-something else. But in his PEP, he basically said that if you have, I'll translate it to async await length so that people can follow.
Right.
So basically, assume you have a function called async def foo.
Right.
So now you can say in your Python code, you can say a equals foo, parenthesis. You can just make a call. And a would be the coroutine object. And then you can await on that coroutine object. Most people just say await foo, parenthesis. And sort of this object is still created. You just don't notice it. You don't think about it. It just works.
Yeah.
So in Greg Uvik proposal, you would not be able to say a equals foo, parenthesis. You would only be able to ever put parenthesis on foo, like actually do the call, if it was prefixed by await. So await foo is legal. Just foo is illegal. So essentially, it makes impossible for you to forget await accidentally. It just makes impossible, like the program wouldn't run. This PEP wasn't compatible with asyncio. So asyncio, like, it wasn't huge at that time, but I mean, people were already using asyncio and building on it.
Facebook was.
So yeah, so it wouldn't be like, we wouldn't be able to say asyncio.gather, for example, and just pass a number of coroutines to it. Like, the API would have to change. So we weren't looking at it, but like, looking back, I think that maybe we should have actually gone that way. Again, like, it's really hard to judge things. Would that actually be better or not? But I think that the problem of forgetting await is like this big gotcha that just is in async. I myself can forget in await, even though I'm the guy like who added the syntax. I can forget about it. That means that other people can.
Right.
So I'm annoyed by it now. Obviously, linters and code analyzers can solve this problem, but sometimes when you're just hacking quickly, you can do this sort of stuff and then be completely dumbfounded why my program doesn't work. So I wish that maybe this particular aspect was handled differently.
Yeah, so like interestingly enough, yes, like the static analyzers are now sort of solving this, but like this sheer case where you're just creating the coroutine and just dropping it on the floor like right away, like could be actually discovered at runtime by Python. Like there is a thing where while compiling the module, we could have like an opcode like about like drop or whatever, where there's a value that we're creating, but we're just dropping it on the floor. Like I was looking into this actually, like, you know, a while back, like thinking like maybe there could be in -x dev, we have this development mode in Python. Not many people use it, but it's there, so we could add this sort of thing. But it turned out that like there is a ton of things where Python is calling functions that are returning a value that you're not interested in it.
Yeah.
So this would raise like very many false positives. It would be very noisy. So yeah, like good point. But it reminds me of the sort of story how async and await were added to JavaScript, because they also were callback heavy in the past, and then sort of upgraded to this world of like thenables and promises and so on. They have async and await right now, but the way it works is sort of more composable in the sense that like you can await in things that are like the fact that a function is asynchronous is not really that important. You can still pass those things like more easily, if you know what I mean. Like if you create like a class in TypeScript, you can just say that there's a def and then change it to an async def like in a subclass, and that's perfectly fine with the type system of TypeScript, right? Like it's incidental because the return value is just different, and so on and so on. So like you're saying that asyncio shouldn't have futures and like those sorts of things, but just like awaits. Like what do you mean should be different?
I think that now it should be just set in stone, and like we should move on quickly about async await and like this mandatory await keyword. I'm sort of thinking about it from time to time. I'm still not sure that would be the right decision, even from the language standpoint, because it's a sort of slightly wrecks the composability of the language, because now, okay, you have the special class of function that you can't even call. You have to have a keyword with them, and that sort of it's also inelegant on its own. Now, the TypeScript stuff, it has features, it has promises, and the async function, basically, if you call it without await, it will just return you a promise-like object. That would be totally possible in Python, except that in JavaScript there is one important difference. They always have an event loop.
Right.
And in Python, you only have event loop when you run it in asyncio.
Yeah, that's a big deal.
In Python, event loop is also almost like an afterthought. It's like a thing that you can install and run as an API. But in JavaScript, that is what runs your JavaScript program, the event loop. So in JavaScript file, you can await at the top of the module. In JavaScript, you can just run and just call asynchronous function, and it will start executing immediately, because there is always an event loop. What would happen in Python if you just executed a function? We would not we would not be able to run it because there is no event loop yet. So if you say full parenthesis and then create loop, well, obviously your program won't run, won't compile. Maybe that would be fine. I don't know, but it sort of it would complicate the internal API design and the internal plumbing and everything else to make this work.
Right, but you are not only working on asyncio and like the async hacks, you also add a ton of extra stuff on top of it that actually many people don't know. And like, I mean, certainly this is a very popular feature, but it has also like a lot of implementation details that are interesting. And this is context variables, right? I don't know if I would call it obscure in the sense that maybe most end users don't use it on the day-to-day, although they should, because how are you going to add context to your stupid log lines? Eh? but certainly, like libraries use it all the time. Like how was like to develop that? Because you have to add quite a sophisticated data structure, right?
Yeah, where did you copy that from?
Context-var hacks. Also, man, that file, I never remember how to pronounce it. HMT, yeah. That has the most beautiful, like ASCII diagram of the entire CPython codebase. Exquisite arrows, like
precision.
Precision, like gorgeous. Like, tell us about this data structure, because you like to add like crazy data structures to CPython. So like tell us about Contextvars.
So that actually started by me scratching my own itch and then discovering that I don't have that itch at all. Like, I'm not using Contextvars. I never use them, to be honest. I knew that they are needed. And if I was writing an application, like any production application, Python application now, I would use them through, let's say, Sentry, because Sentry is using them, or through other frameworks, as Pablo said. So I always knew that this feature is needed and this feature is a must-have. But what I thought I would use it for myself turned out ultimately that I don't need it. So when it landed in Python, I had no immediate use case for it. That said, again, the concept is pretty simple. In a nutshell, it's like you want to have thread local storage, but for coroutines and asyncio tasks. And thread local storage, I don't know, like if it's something that everybody knows, but basically, in a multi-threaded program, you have multiple threads, and sometimes you want to have like a little global state that is only visible to this thread. So in this thread, you say state.a equals spam, and in the other thread, you try to read state.a, and it just gives you nothing because you haven't written anything in it yet, and you write ham string in it, and then the previous thread doesn't see it because it's like local to your thread.
Right.
And the idea is that you want the same thing with async await. Because on the one hand, you don't want implicit state. This is like an evil thing. On the other hand, you also don't want to ruin your code base just by passing some collection of auxiliary data
that's disgusting.
Everywhere, just for logging, for example.
Yeah.
And it also poorly composes, like back to the subject of composability, is that you might as well ruin your code base and pass context everywhere. But what happens if you use some other library that just calls into your code? How do you pass your context then?
Right.
It might not be possible or might not be straightforward to do, especially if that library is complicated and you cannot just pass like a partial or lambda function wrapper. There are some use cases where it just you won't be able to do it, or you will end up with such a spaghetti code monster that you will hate your own code base. So I knew that the concept is needed. The problem is like how do you actually implement it? Because the problem with what makes async IO coroutines and tasks different from threads, and I think it's one of the biggest advantages, is that you can have millions of them. You can have so many of them existing at the same time.
Right.
With threads, you typically have 5 threads, 30 threads, 100 threads, maybe 1,000 threads. But you don't usually spawn a thread to compute something quickly and then you just like throw the thread out. No, you use thread pools and stuff like that. So you can spend some time. You can spend some time in initializing that thread local storage if you have to. It can be super simple. Like you don't actually initialize it in threads. You just always have like thread ID essentially. So you just have a dictionary. But if you had to initialize it, copy it or something like that, it wouldn't be a big problem because you're not spawning threads that often, and the performance of spawning them isn't that important.
Right.
But with coroutines and async IO tasks, that literally is the thing to optimize for. Like, if I add context to async tasks, basically what I want is that I want to see the context of my parent. of the parent task that spawned me. This is where I can have current user ID that I will be logging.
Right. Yeah, right. Because like also to kind of have this global view, like the problem is that most of these tasks, so you have tasks that as opposed to threads, they will be created massively. So you will have thousands and 10,000, like dozens of thousands of these. And also you have two main cases, right? You have the case when like most tasks will look at whatever the parent said and it will not change it. But you also, some of them will start changing it around, right? So you need to like handle gracefully the case when you need to like, propagate it downwards and someone decides to do a change. You don't want to mega copy everything, right? Like that's the main problem.
Exactly. Yeah, that copying is the main problem. And basically, it took me a while to understand how to approach this essentially. And the realization was that I can't copy. Just I have to copy conceptually, but I cannot. Like, how can I not copy something while copying it? And took me some time to just process it on some meta level. And then I thought, well, there's these weird things that they have absolutely no use in real world whatsoever. Functional programming languages, like Haskell.
Shots fired, 147 Maple Street. Requesting backup.
Haskell and Clojure and all of those, like they supposedly, and I'm not an expert in them, but supposedly
they use OCaml at Bloomberg. We use a lot of OCaml.
Yeah,
the camel language. Yeah.
Also, Sally, head of my compiler team, also loves OCaml a lot. So I know the name, but I don't know the language.
I know the name. that tells everything.
Respect to OCaml and Haskell and all of them. I'm just kidding. But that said, I knew that, hey, like I'm not personally using. I only knew Common Lisp and like wrote some code in Common Lisp, but I never tried Haskell, for example.
Right.
But I knew that, hey, like those languages have a concept of immutability, and if they are working at all, they must be smart about like how they implement this sort of flow and pure functions and all that stuff. So I started researching and I found I think it was maybe YouTube talk by Rich Hyperfocus or something like that. I don't remember all the details, but somehow I ended up looking at Clojure, and I knew that Rich Hyperfocus implemented this interesting data structure for Clojure to implement maps or dicts in Python. And the data structure was called HMT. It's essentially a tree. Like behind your flat dictionary, there is this weird, huge tree. There are a lot of interesting, geeky complications in that algorithm. Like it uses some bit encoding hacks to compress the data structure in memory and whatnot. The interesting part about the data structure was that it was new. Like it was invented in 2006 or 2008.
Right.
And I was looking at this problem in probably 2015. So like 8 years later, I was looking at the white paper of some data structure that is like literally brand new, like in the world of data structures.
Right.
So again, it took me a couple of maybe days to understand how it actually works, because it's like now it's obvious to me, but back then when I was looking at it, like what is all this bit magic crap? Like why do we have this complex bit hacks essentially everywhere? What's going on with this tree? But then again, like my approach, so I just opened Clojure source code, found the implementation of this data structure, followed it along. It's written in Java and was easy to follow. And I'm okay. Like this is the solution for all my problems. I just need to implement it in C. How you do it? Well, you open one tab, one column in your editor Java code, one column in your editor in C code, and just start writing C just to replicate the same flow and the same thing. And I think in about a day, I translated just enough to basically have a demo where this data structure worked. Obviously, it didn't have iterators. It didn't have like all the methods that Python mappings usually have.
Yeah.
But it had an operation to add a key, and it had operation to create a new copy of this map without the key. That's it. That's all you need to prototype this. And it worked. And it worked beautifully. And essentially, like basically, no matter how big your map is, or dict is, it can have 5 elements in it, or it can have 50,000 elements in it. Copying that dict and changing just one key in it was still super fast, like microseconds fast. And that was incredibly impressive. And that was the key to sort of to implement those context variables, because now I had the actual data structure to super quickly inherit context and keep modifying it,
Right.
so that any modifications you make, your parent async task just doesn't see. So the context can propagate downwards, but it cannot go upwards.
Right.
Very cool. Yeah. So this reminds me that this is all around like immutability, but in a way where, okay, you can still like make changes to it, since like immutability where you cannot make any changes in your program like would not be very useful. So in the end, you have to have some API to be able to make changes to your immutable data structure in an efficient way.
Small correction, it's still immutable. Like you don't change you never change anything. You can create efficient copies with a change of something. So if you have an immutable dictionary that has a key A, set to 42, you can create a new immutable dictionary based on the original one.
Right, but anyone that has a reference to the old one won't see the change.
Yes, like under the hood, there is a reference, some structural sharing between those data structures.
So my point is that from the point of view of the user, if I have a dictionary, right, and then I pass it to this random function that I don't know what the fuck is going to do, then I know that my dictionary is not going to look weird after the function finishes. Because
exactly.
If someone wants to make a copy, they can make a copy and some shit can happen. But in Python,
Right,
a lot of the weird code that takes like weeks to debug is because I have my data structures and then I pass them raw to this insane world that I don't control, and then they can mutate it or like normalize because like they decide to use it, right? So in that sense, that's a good immutable like feature that you can basically the feature guarantees that I can do this and know that nothing weird is going to happen.
But where I was going with this was that you do have a PEP that is still under consideration that was designed to make this HAMT structure into a data structure that is usable from Python code, right? Like it's called frozenmap.
Well, and create an entire module.
Is that still like something that you think might happen, like in Python? Like what do you think? Where do you think that stands?
So I think that immutability in Python is something that a lot of people don't know about, even though they use it daily without being aware of it. Like strings in Python, for example, are immutable. Tuples in Python are
unless
immutable.
You want them, unless you look hard enough, like if you look at this, I mean, immutable, but like yes.
Well, of course. I mean, you can break everything if you have access to memory, but
yeah, it's not like the half of the internal representation changes when you compare Unicode strings between themselves, right? Like that never happens.
Well, but again, as a user, there are some guarantees that the content will not be changed, but. In like Python engineers, they just don't have this muscle of using immutability much.
Right.
That's the thing, and I think that adding frozenmap to Python is cool, given that a lot of code is already there. Essentially, that powers that Contextvars module. But will it actually be used that much, or how? Like, where do we put it? Do we put it in the collections module, or like what's the actual?
Are you claiming the fit then? This looks very the fit.
No,
like.
So what I'm saying is that potentially we need to just add more to it. Like we need to add like an actual use case for those data structure to actually make sense. Because like if we add frozen map, then or frozen dict, the next question is going to be, where is my frozen list? Now I want the same structure for a list.
But that's kind of a slippery slope, no? That's a slippery slope. Or you want to add the entire collection?
Well, I think lists and maps are sort of mandatory. Like we should have them. Like I should have, if I have a mutable map, then I should have an immutable list where I can store like millions of items, and I can create a new list in microseconds that has all of those items plus one more. That will unlock like a lot of like creative things that you can do with immutable data structures. There's a lot of power, and when you combine lists and dicts, you can express anything. Like anything is representable in that model.
Okay, but it's going to happen. Like people are going to have immutables in the standard library.
Oh, hopefully, yes. There is a PyPI module right now that I think works.
Yeah, but it's quite popular actually.
Is it?
Yeah, I mean, it's not mega popular, but like in the sense that it's not URL 3, right? But like it's quite popular. Like people depend on it, and
Well,
yeah.
maybe we should just wing it, but and merge it, but or get it through.
Well, there's
the-
a PEP. There's a PEP. There's a PEP. No.
Sure, get it through the approval process.
Hold your horses. As part of the steering council, I compelled you to okay. No. But submit the non-PEP. Submit the non-PEP. It's just rotting there, dude. Like I would love to accept that PEP.
Sure.
Not a binding statement by the steering council.
So I keep forgetting about that PEP. Most recently, when I thought about it again, was in the context of my experimentation with subinterpreters. I had a talk at a previous PyCon US.
Yes.
And by the way, I'm going to have a weird talk this conference, which you should visit. That talk, most likely you will remember for the rest of your life. I promise you that.
Yes, just go to PyCon. Yes,
something
will happen.
Something will happen. Something will happen.
Something tasty.
Some people will be embarrassed. Some people.
Maybe two people.
Maybe two people.
Yes, they may or may not be related to async hacks in different ways.
Maybe or may not be on this call.
Yes, we don't know.
We don't know that. We don't know those people. Anyway, on the previous PyCon, I had a talk about Memhive, which is a way of sharing data between subinterpreters. And I don't want this to make a long conversation, like just 1 minute essentially, because Memhive is still not there. I still have to find time to finish it, to make it actually closer to some state where other people can play with it and build something with it. Right now, it's still an early prototype. But the idea is that you have those Python subinterpreters, and each of them has its own GIL. So essentially now you can run Python programs in the same process without the GIL limitation, and do it now without waiting for no GIL branch to merge and without all the ecosystem to catch up. And this is interesting, but there is a problem with it. And the problem is that how do you share data? Because those interpreters are pretty much entirely isolated.
Right.
But this is only when you think about it from the standpoint of like pure Python land. But if you think about it, what can I do if I look at this from the perspective of a C extension to CPython, and suddenly, oh my God, I have access to the entire process memory. I can pass pointers between those subinterpreters. I can actually share data.
Right.
If only I could share this data and be confident that my program will not crash of seg faults and whatnot. Because like if one mutates and the other mutates, like what happens? Or if one is using your Python object, one subinterpreter is using your Python object and you have no use for it, so it's garbage collected, what will happen? A seg fault will happen.
Hopefully, yes, that's what everybody wants from seg fault. Yes, hopefully. Yeah,
just really, really hopefully seg fault will happen if you do that. But this problem sort of goes away if you use immutable data, because with immutable data and message passing, because if you use message passing and immutable data, you have a guarantee that, hey, like if I share this immutable dictionary with like many, many fields and it's immutable, it means that I cannot mutate it anymore. I, the one who created it, cannot mutate it anymore. Now, the only thing that I need to care about is me just not dropping it on the floor and let it get garbage collected. But other subinterpreters can read this data structure safely without using any locks. You don't need locks when you know that this data is frozen in time.
Yep.
So this is the interesting insight that I had, and I created a prototype around it, where I could actually share like arbitrary amounts of data with very little overhead across subinterpreters. Again, ultimately, it needs me coming back and just like finalizing the actual API and making it a library and not a hack, not a prototype. But potentially, this is where immutable data structures can shine. And then I was thinking, now we have an interesting use case for immutable types in CPython, because now we actually have this immutable, we have this frozen map, and we can have frozen list. And now I can say, hey, like I have 5 async IO things like async IO threads or processes, subinterpreters running in the same process, and now they can exchange those immutable types.
Yeah, but you know what happens? Like from a strategical point of view, is like you're going to end with a ginormous PEP that you're going to propose the ball, like everything, like it's just immutables and the main hive. Like you want to just push your old pep and like just say, oh, this will be very useful for some interpreters.
It's a building block.
Yes.
Yeah.
It's a building block, but that magic that I've done it in Memhive, it requires some modifications to those structures, like add some extra memory overhead and whatnot. So
maybe look at it so you don't shoot yourself in the foot when you merge the other one. But like, you know, a lot of people, I think, I don't know what people think. You know, if you are listening to this and like immutable data structure, just send us something on some channel.
I think if enough of you say us something, we can just merge it without Pablo even approving it.
No,
right,
the Steering Council doesn't like
No?
it. No.
This is a non-binding statement by the Steering
And
Council.
also, I'm just 1/5 of the Steering Council. Also, what I say here, it doesn't count.
True.
Right. What I'm thinking though is like Yury is incredibly prolific. Yes, prolific. There's things like syntax highlighting, async await, gel the database, context variables, frozen maps, memhives, and so on and so on. But there's even more, right? Like the main event loop of async IO is not the one that people are using. The built-in one is like for toy applications. The production one that everybody's using is called uvloop, and that's also Yury's creation. So now I have a very stupid question about it. Like the dumbest question you can ask, but like it just occurred to me the other day. Do people these days think that it's Astral who made this because it's called uvloop?
Wow, they stole from you.
I know Charlie, the founder of Astral, but I think I actually
You're saying
did.
it as, I know where he lives, so I can just make him a visit.
I think I actually did ask him why he named UV, and he didn't have clear answer. I think they just like were looking for a short command.
Yeah, that's the classic excuse. It's like, oh, you know, it just happened.
Maybe.
No, we like
Charlie.
Charlie's cool.
Yeah. He sounded genuine, so I think it's just a coincidence. uvloop is named uvloop because of libuv, and libuv, the underlying actual networking library that does heavy lifting. I don't know what UV is there. Probably universal, because they wanted to have
Universal? No, it's ultraviolet, no?
So I thought like it's libuv because it was essentially like this sort of counterpoint to lib event. So the UV was like a micro event. I think it was like as a smaller library that is supposed to be much better than lib event. Like that's what I thought when I first saw libuv back in the day.
Could be. I'd assume that it's just about it being universal sort of library that unifies different flavors of Linux, Unix, Windows, and all of that. Like universal.
Three people, three explanations.
Yeah, exactly.
I have the official answer here. What does UV letters stand for? You're not going to believe it. Unicorn velociraptor. It's in the logo.
Okay.
Well, apparently it's not the official answer, but there is a. You go to libuv/uv. There is a discussion in 2021 that it says, "What does UV letter stand for?" And most of the agreement is that it's just unicorn velociraptor.
Makes total sense.
But the logo is a T-Rex, right? Which is even weirder.
Yes, and then there is like
look at it.
It's kind of weird.
It's a unicorn T-Rex, not a velociraptor. It is very strange.
Oh, it's in the README actually. Oh no, the PR was closed. It was censored.
Oh.
It's an internal joke. It's an internal joke. Oh, it's an internal joke. It is privileged information. So it stands for unicorn velociraptor, but they closed the PR to add it to the doc.
But Pablo found it.
And the PR was saying U or unicorn is a reference to universal and multi-platform. V or velociraptor is a reference to velocity and high performance. But it's unicorn velociraptor. Okay, so now you know. So your library now stands for unicorn velociraptor, not like Astrals. You know,
I should update the benchmarks for uvloop because I heard from Kumar, who works on asyncio a lot, that apparently the micro benchmarks that I have now, asyncio is close to performance in uvloop, or maybe even better.
Oh,
so we should.
No, how can that be? uvloop is C.
Uvloop is C. Our event loop is in Python. I mean, the asyncio event loop is in Python, but
yes,
I don't know. Maybe it's more efficient than how it
sounds very suspicious. Nah.
Well, that's the power of micro benchmarks. So they can be
they lie. That's, lies and micro benchmarks.
But what I'm saying is that I need to actually take a look at what's going on there. And
wait. Intermission. But speaking of Astral,
yes,
it's a company founded by Axel or Excel and Guillermo Roche, right?
Yeah.
Just like Gel. Who is this company? Gel or Hell in Spanish. And people love RAF and UV. Unicorn velociraptors are cool indeed. So, but what makes Hell or Gel lovable? What's the killer feature? Why people want to use Gel? Like your company, not the shower thing.
Yes. So Gel, it's a big gear change from Python and the velociraptors to Gel. Anyway,
It was a good segue.
It goes back to my urge of not understanding why things have to suck when they don't have to suck. Databases is one of them. There is only a tiny proportion of engineers on this planet who actually love dealing with databases or relational databases more specifically. Most of us either treat them as an afterthought or just ultimately hate doing that. There is a bit of a Stockholm syndrome with engineers and databases because we know, for example, that, I don't know, like SQL Alchemy API is huge and complex, and like writing actual high-performance queries in it is like really painful.
Yeah, it's tricky.
Yeah, we know that SQL is poorly composable, and it's like, you know, SQL Alchemy API well, you might not know SQL well, and vice versa. Like you have to learn two things now. And if you want to use Django, it's like three things. It's yet another API flavor on top of the database. And then the data model itself, we don't think in tables, neither as human beings nor as engineers. It's just like not what we think, not how we think. We think of objects ultimately, or records or something like buckets of information essentially.
Mm-hmm.
And in our head, we do not perform a join between three buckets of information.
A left outer join.
Yeah, this is just like, okay, like I have a connection, like this thing is connected to that one. This is how your brain works.
Yeah.
So why are relational databases like that fucking weird? Like why? Why do they have tables? And the answer to that is that relational databases are performance optimization. Mm-hmm. It's that simple. There is certain mathematics behind it and whatnot that basically allows you to have fast storage and efficient storage in terms of space. And tables was how they are structured. It was the most obvious way of how you basically translate that math into software. But it's not the only way. Absolutely nothing sort of prevents you from having a nice to work with higher level data model, which would be just like immediately sort of accessible by Python and JavaScript and relatable by those languages and by you, the user of the database.
Right.
Same about the query language. Like SQL is kind of awkward. Probably data scientists understand it and like it, but for engineers, typically it's a big sort of context switch when you have to write Python code and then you have to write SQL, because SQL is incomposable. It's just like it doesn't have the same sort of flow that your typical programming language has, and it hurts. It hurts everything. It hurts the quality of the queries that we send to our database. It hurts the quality of the ORM libraries that we can design around this query language and around this data model. It hurts your day-to-day engineering, actually, in ways that you don't even understand, because what we currently have, the status quo, is kind of the best that there was,
right, for
half a century. And my question to all of this is that is that how it should be? And my answer is that no, we have to move on. Relational algebra and all of that mathematical crap can easily be facelifted, uplifted, and you can have nice data model to work with it. SQL or your query language doesn't need to be horrifying. It can actually be composable. It can actually be logical. It can actually be readable and refactorable. And just basically just do it. This is what we've done.
So you keep mentioning that SQL is not composable, and that with GEL you have HQL, which is. So can you give us some examples of things that you can do in HQL that you cannot easily do in SQL?
Sure. In HQL, for example, you can select a user. And for user, you want to select maybe their email. And then you want to select their friends. And for their friends, you also want to select their email and their friends and friends of friends and stuff like that. So this sort of like hierarchical selects are just not possible in SQL because SQL works on tables. Ultimately, it operates on tables. It is sort of possible with like array aggregates and like there is way. I mean, ultimately, our query language compiles to SQL. This is the little secret that we have.
Sure.
Is that we're building on top of PostgreSQL. We're essentially an alternative front end to PostgreSQL. We are ultimately compiling our data model to proper table layouts. We ultimately compile our query language to some advanced SQL that you will not be writing by hand. But in your typical SQL use, you just cannot do those hierarchical queries, and then you're losing performance because you have to fetch your data in multiple round trips to the database. That is bad for your database because more queries. And it's bad for you because, well, more latency. Your backend to database connection is never instant.
And you do those round trips typically because like subqueries in SQL are sort of weird. They behave differently in selects and differently in updates. And, you need to know exactly the syntax to allow passing data between them and so on.
It's without risking boring everybody too much on this call. It's just like the SQL nature. Like how do you like if you don't have this sort of like ability to nest your data, right? How do you do it? Your data becomes flat. So imagine that you have a hierarchy that 5 levels deep. If it's deep, it means that if you have nesting, your data is going to be nicely represented on the wire, right? Like nicely encoded and packed. But if you don't have nesting, it means that you're going to have a super wide result table, a bunch of which is going to be empty. And it's going to be flat, like every row is flat.
Right.
Yeah, right.
And then you receive all that stuff, all that crap, and you have to iterate through those rows and stitch them together on multiple levels. So now you have your Python code actually doing work just to sort of make sense of this flat ironed data sheet, which can be super wide and super big and super inefficient to work with. And this is just like it's just me scratching the surface. Like really, GEL is a very comprehensive attempt at just simplifying and streamlining all of your database operations. You can install it locally in a few seconds and multiple versions in it in parallel. And you don't need sudo or anything. It's just like really that easy. You can connect to your local GEL database without specifying port numbers or messing with TLS certificates. You can do the same with the cloud instance and creating cloud instances seconds. You can have your data model where you have mixins and multiple inheritance, just like Python. And you can specify abstract types and compose your schema out of reusable primitives if you want. You can have a query. We have a query language where it's like a mix of GraphQL and SQL, where you can work with nested data. You can refactor a query easily, just like you have a similar experience to what you do in Python, essentially. This is how it feels. A query language that doesn't feel alien, and that actually gives you data that can fit straight to your UI, for example, without worrying too much. Is the schema where we figured out a lot of things like access control, for example.
Right.
I think in GEL, access control is like literally best in class.
Wow.
It's better than what you can do with RLS. Just recently, I gave a talk where basically the organizer of the conference told me, "Hey, can you give a talk in such a way that if your product ceases to exist tomorrow, there still would be value in this talk?" So I thought for a while, like, what would be the value for this talk? And the talk was super quick, like 10 minutes. What would be like the main thing that we did in GEL that other databases should copy, for example? And after thinking about it for some time, I realized that thing is actually schema. It's that your schema has to be the first-class citizen of your database. Like if you think about it, your Postgres has schema, right?
Yes.
Do you see that schema?
You can query it.
You can query it, but it's somewhere. It's sort of hidden from you. It's remote. You ultimately create that schema using some DDL commands or whatnot, or maybe your
I see what you mean.
Maps to that schema, but that schema isn't accessible to you. That schema is not part of your developer experience.
I see.
So if you manage that schema with DDL commands, then all you have is those DDL commands, and it's super low level. And if you hire a new engineer, you'll be looking at those DDL commands like, what is this? They will probably be using some UI maybe to visualize the database, but it's like it's a huge friction point. You don't have it. Or maybe you use Django or SQL Alchemy, but then Python was never created to be a language for describing tables. It's not its thing. So there is limits to what you can express in your Django model or in your SQL Alchemy model. How can you map it? And when you do that, you're losing a bunch of things that Postgres allows you to do, like maybe have like some non-trivial queries in those tables. In addition to like regular columns, have some columns that can be computed, for example, dynamically for you, or maybe cached, computed once and then cached, stuff like that. So schema is just not there; it's hidden from you. And one of the things that we started with. And then the whole conversation about migrations, like everybody hates schema migrations. There is not a single person on this planet who loves schema migrations in relational databases. Not a single one. So the question is like, why? Try to answer this question. Why is it this way that schema migrations are always managed by some third-party software? Your schema is in the database. Your database is the center of truth.
Right.
This is the place where you want to reason about schema and figure out how to migrate it. But somehow the database is like, no. This is not my job. This is your job. You manage it. And then you try to manage it with all those ORMs, and ORMs are maybe fine, but then what if you have Python and Go in your backend, or Python and Rust? Do they use different ORMs to map to the same thing? And now it's awkward. It's becoming awkward immediately. So my advice is that every database should ultimately follow what GEL did. And with GEL, schema is the first class citizen of the database product. It doesn't matter what language you use, Python or JavaScript or Rust or Go. Schema has its own declaration language, which is compatible with the query language, so they can mix nicely with each other.
Same language.
The database enforces the schema just like Postgres, but unlike Postgres, it also has the migration engine built into the database itself. So when you create a migration with your command line tooling, for example, the command line tool is doing an absolutely mind-blowing thing. It communicates with the server back and forth, exchanging the schema, and with you, the user, asking you for feedback, and you, the three of you, together figure out like what's the deal about the schema migration. But because it's implemented once and every programming language can enjoy the same flow, it removes a lot of cognitive load from you, just having the schema in one place.
Right. It's not a function of Rails or Django or whatever. It's just built in the database.
But then, if you do that, then it opens up doors to just absolutely incredible things. We don't have them just yet in GEL, but this is where we are going, where you can have online migrations, for example, where you can have rollbacks, etc. When the database is aware of the schema and tooling and everything else, it gives it absolutely immense power, because suddenly your database stack is in control of its fate. And GEL is the only database product that thinks this way, and this is just mind-blowing to me. Anyway, to make this short about GEL is what will supercharge your Postgres. Open geldata.com, GELDATA.
Gorgeous webpage. Gorgeous.
Oh, yeah.
Yes.
Coded by yours truly, the background animation. So if you want to look at, admittedly, a beautiful WebGL shader,
gorgeous.
GLSL.
Take a look at the web page. Might be blowing your mind.
It does look fantastic. So if anybody's interested in actually trying this out, but they might not actually have like a production use for this right away, but they would want to create a project in it, like actually play with it for more than just going through the tutorial, like do you have any suggestions, like what they should be working on, like how they could test GEL out?
So check out the website. We are still sort of dealing with the aftershock of the rename. We're structuring the documentation and whatnot. We have a bunch of templates that you can take a look at, but ultimately take a look at the front page. If it resonates with you, you will have an opportunity soon to build something. We are going to be organizing and announcing a hackathon. It's going to be a Python-themed hackathon.
Wow.
I will not tell exactly the tech that we expect you to use or anything, but consider this as a head start. So if you had a thought or an idea of implementing something for yourself, or maybe or maybe starting a future company and you just wanted an extra kick to just go and like build an MVP of that product or an idea, this hackathon might be a nice opportunity for you. Besides just us having, I believe, fairly generous prizes, it's going to be judged by someone very, very special in the Python world. Very special. Not just one, but by 3
Gukash.
very, very, very special people. No, I'm sorry, but Lukash is not that special.
No, not that special.
I'm kidding. I'm kidding.
Special.
Lukash is obviously special, but
I know my place. I know my place.
but I hope that this hackathon is going to be an exciting one. So take a look at the website, and if the ideas that you see there resonate with you, consider using Gel for your next project. But most importantly, in a couple of weeks or maybe 3 weeks, we're going to announce that hackathon. I think it's going to be a pretty interesting event.
Awesome. So on top of having your own company and working on the rename and the new features of Gel and hackathons and so on, and being a dad and being a core developer, you are still actually active in core Python. So just not long ago, you worked on a very impressive new feature for asyncio. And to discuss this, let's switch to our typical part of the show, which is called All right, so what is that change? What is the feature that you wanted to add to asyncio? What does it do, and why should we be excited?
So I'm not as active in CPython as I wish I could be, but I still enjoy working on it, and specifically enjoy working with you guys and working with other Python core developers. So I went to this sprint, Python core developer sprint. This is why you should become a core developer, because you can then come to sprints and work for free. That one was for about, I think it was a week long. Was it at Microsoft? Oh, was it Meta?
It was at Meta, yes.
Meta, yes.
It was at Meta. Just opened GitHub, opened the asyncio issue, opened the asyncio issues and started looking through them, and like, okay, like this one is fixable, fix that. That one is fixable, fix that. Reviewed that. And I saw this issue that I thought honestly would be a day of work to fix at most, and turned out to be
famous last words.
Yeah, turned out to be ever slightly longer than that, maybe 2 days of actually focused work. Anyway, that issue was about what bigger companies actually need, or companies that run relatively serious asyncio deployments and where they want to profile their stuff and spend time profiling their stuff and analyzing it and fixing it and optimizing it and all of that stuff. And the idea is that you want to be able to profile asyncio programs. You want to do that ideally with little to no overhead in production, because what's the point of writing your own benchmarks? You have your application, just profile that and make sense of it.
Uh-huh.
And on the surface, the idea of it is relatively simple, which is maybe asyncio can do a little bit of additional bookkeeping behind the scenes, just so that from within your Python program, asyncio program, you can just print your call stack, essentially. Your coroutines that lead to this point of your program, and also all of the tasks that led to your current task being spawned and created.
Uh-huh.
That bookkeeping on its own is not that complicated. What is more interesting about it is how do you make it now introspectable from the outside? An obvious solution would be to give you an API to capture call stack, and then, I don't know, you open a network connection and you just dump that tree. But that is slow. This is no longer low overhead. This is pretty much high overhead, like right there.
Well, and maybe insecure. There's a socket that you can connect to.
Yeah. So all those complications, and this is where the wonderful world of eBPF probes comes, right. And maybe Pablo can tell you more about that.
Oh yeah, but I need some maybe a change of dressing, like just hinting there something. But yes, like this is quite a big deal because, and this is what the industry is going to, right? Like eBPF is basically how the modern profilers are doing things this day, because like not only allows you to have like super low overhead, like we are talking extremely low overhead ways to introspect your application, but also the kernel and have really the real vision over what is going on with your application. Because like normal profilers, you're reading and then it says, oh, read took like this much. But why? Like what is the kernel doing? It's just like buffers, or what the hell is going on, right? So having that is a big deal. And this is the next thing in profiler introspection. But asyncio is quite challenging here, right? Because like asyncio doesn't have a stack in the traditional sense. All the eBPF and all the different tooling that looks at performance optimization, they normally like just unwinds the stack and say like, okay, the application is doing this. And when it answers that question, it's basically telling you what the stack is. But asyncio basically is going to have one single thing, which is the current task.
And the event loop.
And the event loop above, right? So, but it's not going to tell you who scheduled that task or what task is waiting for, or like who is waiting on that,
or how many there are.
Yes,
even.
like you're missing everything. Like it just sucks. Like especially like if you do this ever from the outside, you're going to have like nonsensical results, right? So that's quite challenging for all the different tools, not only profilers but also debuggers and also like memory profilers, like all the thing. Like it's really confusing to use asyncio. But now we have the real deal, which is this new PR. It has the foundation to basically like allow these tools to like do a bunch of work, but like that now is possible. Before it was not possible, to basically reconstruct almost everything. So you can literally have this graph, as Yury likes to call it, because it's not a stack anymore. It's a graph, or like all the different tasks and the relationship between those tasks. So now you can build all sorts of things. You can have debuggers, but you can have also profilers, and in the future you can have this eBPF tooling. Or other things like Memray and PyStack are tools that I maintain that do this on a day-to-day basis. But we can have all these different toolings like working with asyncio, which these days if you're building a network application in Python and you're not using asyncio, you're like, what are you doing, right? Like like most of these things like now run on asyncio, but unfortunately they are really, really difficult to debug. And like this is not a made-up problem. This happens all the time. Literally, in the past 6 months, I have to deal with this problem and suffer the consequences. And I'm a core developer. Like I know what I'm doing most of the time.
All the time.
But like this is extremely painful because like now you have one of these tasks that is slower than the others, and really finding it, if it's not just I/O, which is like easy to do for some tool, like it's really annoying. It's really difficult, and when you find it, you don't know how the fuck you arrive there. Like I have so many examples just in the past 6 months.
Yeah,
I developed the tools that help with this, and I still struggle. So having this solved is just a major thing, because it's not only like solving a problem; it unlocks a whole realm of solutions to many different problems that happen on top of asyncio. It's a foundational change, and it's also a tricky one.
So we both allow now to introspect async IO from inside the process with asyncio.graph. You can already read the docs on the dev docs on .python.org. And we allow for external introspection, about which Pablo was talking. And guys, like it sounds to me like this is enough of an interesting topic to warrant like an entire talk about this. Like, am I right?
Yes. Like maybe something will happen on PyCon, Yury? Like
I heard rumors.
Well, what happened?
From some people in vegetative state.
So if you go and look for the schedule, you'll find that on Saturday there is a bunch of talks. In fact, like Pablo is obviously like, over delivering as usual. So he's having 2 talks that day. One of those is with Yury about this very topic that we're talking about now, and the other is sort of related, actually, right?
Nah, it's about how to build attaching debuggers for CPython, which is still not approved, but like maybe some news soon about the PEP. Like maybe when we release this, like there is an official thing, maybe rejecting it. Who knows? We don't know. We only will have someone in the Steam Council that will tell us the future of this.
Wow, would be very useful.
It was not involved in the decision. I recused myself, obviously, because it's my own PEP. Also, just to
How
be
gracious of
absolutely clear, I have something to say, and it's important because now it's binding. Yes. Okay, look, I have these talks, but it's kind of like not really true. I have just half of the talk because I'm giving half with Yury, right? And then you will say, well, you have your talk, so it will be 1.5, right? And this is okay. So that is like,
But
no, because I was thinking in that pep that I'm like showing. I'm not the only author. I'm the main author, and I have the idea and whatnot. Like then I have my brilliant coworker Matt Wozniacki that was there, and also we were super lucky that to have Ivona, which is the last person to join my team at Bloomberg, that wanted to. She's a junior engineer that joined the company really recently. Brilliant person, fantastic. Like she's amazing. And she joined forces with us, and she's going to do a bunch of things, in particular also the Windows implementation, which is like not easy.
Yeah, right.
And I had this idea, and I said like, okay, well, what if I co-present this thing with her? You know, like she like that's the half of the talk, because like she knows about these things. She has like participated in the PEP and the decision and whatnot. And you know, she was thinking about it because it will be her first talk about in front of like hundreds of people. You know, what a baptism of fire.
Yeah.
But she has said yes, and I'm saying it officially now, so you cannot say no because now everybody knows. So yes, Ivona is going to give half of the talk with me. So half
and a half is one.
One talk. So Pablo is going to do one talk at PyCon.
Okay,
yes,
that sounds more fair.
Yes,
Cool.
Yes. Go Ivona.
So now we are closing in on 2 hours of an episode. So I know our listeners are used to us going pretty long, but we still wanted to at least do the 2 most significant rounds of changes in Python since the last episode. So let's go very quickly through those. And everybody who made changes since the last episode that we will not cover today,
it's our fault.
We're very sorry, but it's not you, it's us.
Yes.
The episode would have to be 3 hours long.
We will be like feeling very, very bad after that. We promise.
Yeah, but ping us for larger changes that you would want us to cover next time. We are very open to just going out of order. Like it doesn't matter. We come up with the rules. Just like Pablo decided what the rules about one speaker, one talk are for him in PyCon. As you can see, like
I asked for permission. I asked for permission. Yeah. I emailed the organizer.
Everything's made up.
I did the responsible thing.
All right, good. So now, what's
Going on
in CPython?
Well,
let's start with the faster Python changes.
Yes, and we have a big one. It's fantastic. It's a change by Ken Jin. Find out, like in collaboration with a lot of people, but the change was by Ken Jin. It adds a new interpreter. We will explain what that means. That makes Python a lot faster. Like I think it's 40% in some insane workloads, but like mostly it's 10% on geometric benchmarks, which is a lot. It's a lot.
It is a lot
for a single change. That is 200 lines of Python code that generates some C, that generates some assembly. That's the thing. But it's insane. This is 2 releases of speedups at a normal rate. Amazing. But what the hell is a new interpreter? Has he implemented a new version of CPython? No. We call interpreter 2 different things, like the same way we say the Python virtual machine, and doesn't mean that it's a hypervisor in the middle, right? So this is not the interpreter you think it is. It's just the evaluation loop. It's the CLVAL loop. So which is this? How many interpreters do we have right now, Gukesh?
Now we have the jitting one and the non-jitting one. And the specializations that we are like reverting from. So I would say like 3.
Well, technically we have more. Like we have, I mean, depending on how you count, but yes, like we have the normal CPython switch case with computed gotos.
Yes.
Then the one without computed gotos, because that's what Microsoft uses, because the Microsoft compiler is a suboptimal.
Really?
Yes, Microsoft compiler implements whatever they want of the C standard. I mean, technically, okay, yes, computed gotos is not part of the C99 standard, but like everybody fucking implements that, but not the Microsoft compiler. So technically, if you run CPython Microsoft, there is no computed gotos. Yes. And then we have the optimization compiler, and then the JIT.
Yes.
I mean, technically, the JIT is experimental. So, like, would you say is there? Well, no. Well, this is the 4th one. There is a new one. And this relies on some super cool attributes only on modern compilers. So modern, not only Clang has them, not GCC. So you're using GCC, you cannot use this optimization. That are attribute must tail and attribute preserve none. And this is very cool. Do you know why it's so fast, Gukesh? Because the real secret sauce is in the second one. It's preserve none. Preserve none tells the compiler, okay, when you generate this assembly, you don't need to save any fucking registers. You just throw them away, and then the next caller can use everything.
Yeah.
And then basically, conceptually, it will grab every bytecode, and instead of having a ginormous switch of bytecodes, it will compile every bytecode into this tiny little function that lives outside the entire world, and then will use the must tail attribute to be able to stitch them together. So you can basically
like the JIT, sort of like a similar idea to what the copy and patch is doing.
Yeah, in that they use this mass tail to do the stitching for the copy and paste. But yes,
Yeah.
so now with those two things, the compiler, and you can actually see looking at the assembly, the compiler will start throwing away all sorts of insane like register pushes, pops, and savings and shit because it knows it doesn't need to preserve those, and it removes like a lot of extra instructions that are not needed, but also allows the compiler, because the mass tail call, to look at the whole trace and optimize everything, especially when you run with LTO and PGO, because now LTO and PGO have more freedom to reorder because every single instruction is its own world. And that gives you an insane amount of performance. 10% is so much that is much more performance than the entire JIT.
Yeah, so far it is. But to be clear, this tail call doesn't mean that anybody who is writing code in Python can use tailing calls.
No. It's in C. It's all C. It's,
Exactly.
It's basically saying that it saves registers.
Implementational detail.
Yes, it doesn't. Tail call means that it's not a frame being created in C. It's not Python. There will not be tail calls in Python. But yes, it's really, really efficient. So really fast, and also like it's quite cool. There was also a similar idea on Google's protobuf interpreter by Lua Digin. I hope I'm pronouncing it correctly. So it's not a super new idea, but it's quite new to think about how to implement it in CPython. And especially what is really, really, really cool is that it's just 200 lines of Python code that generates a bunch of bullshit C that then it does the magic. So mega maintainable. So
it's rare.
Like performance by line. Amazing. So thanks Kenjin and all the faster CPython team and everyone involved here, because it builds some shoulders of giants kind of situation. So yeah, but quite cool.
All right. What else?
Okay, so now we're going to be a bit faster because this was important, because 10%, like people want to use it and build on clunks, but we're going to be a bit faster. So now we have glob.glob. Now it's quite faster because it uses less system calls. And this is a PR by our friend Barney Gale. He has a beautiful PR, well explained. When he implemented this beautiful 200 lines of code, you see, all the PRs are 200 lines of Python code. When he analyzes like glob.glob and all the functions that are being called and all the things and find all the system calls, and he optimized the hell out of the thing, extremely well job, gorgeous. Then we have another PR by our good friend Brandt, when he added boolean guards for narrowing types to values in the JIT compiler. So this is just adding more guards so the JIT knows like what the different types are, so they can optimize a bit better. And then we have by Neil Schumacher. You heard from him in the interviews that we did in the Meta Python Core Developer Spain.
Yep.
He added a prefetch in the GC mark alive phase. And why is this good? Because like prefetching is all this idea of like telling the CPU, okay, just grab this memory because I'm going to use it in a second. Why? Because I'm visiting a linked list. And what happened in a linked list, that there's a bunch of pointers that are one after the other. So, and like every pointer is in a different place of memory. So it will be good if meanwhile you're processing a pointer, the CPU is also prefetching, like very smart. So nice, Neil. And then we have this change is really cool. It broke the billboards a bunch of times, but now we have it.
Yes.
So Mark Shannon, our good friend Mark Shannon, that for a long time has this battle against the uvloop having a limit because he proposed this idea back in the day. I don't know if he ever realized it in a PEP, but he proposed it in a language summit to have a limit for everything in Python. And he proposed 1 million as the limit. So you will only be able to do 1 million calls and will have 1 million coroutines, which was a bad idea because people create more. But anyway, so since then, he really wanted to just not have stupid arbitrary limits for the C2C call. So like when you call the uvloop all the time, you receive the the recursion error, that's an arbitrary limit of the C call, so it doesn't Stack Overflow, right? Because in C you don't get a nice exception, you just blow up. But then he said, okay, instead of having this ridiculous limit, you can do something that technically is kind of like not portable, but it's portable enough, which is like measuring the actual stack that you have left. And then you detect when you're going to Stack Overflow, and then you say, I'm going to Stack Overflow now, so I'm not going to continue. And then you just block. It is like on some APIs using pthreads, so it depends on pthreads, so Windows is different, and it broke the billboards, and because, AX didn't have half of these things, but he has like a nice, good version now that I think works perfectly. and it has addresses and node counters, which was the thing that we were using before. Fantastic. Hopefully we have it, which means that you can abuse slightly more the C calls, the C2C calls, right?
On macOS as well.
Yes. So you can now, Gukas, do you know what this means? Now you can go and set set recursion limit to a stupid ludicrous value because Python to Python calls are free.
Yes.
And C2C calls now are safe. Yes.
Very good.
Fantastic. Brandt also added dynamic exit that was used when tracing into a generator, but also when tracing into functions. This made some benchmarks much lower to compare with the JIT-off, which is like kind of like that's why we remove it. And this fixed the most pathological cases by an overall 1% speed up. Very complicated, which shows why Brandt is very smart. Also, the last thing that I have in my list is also Mark Shannon. Mark Shannon again, twice Mark Shannon. Some people will argue there's too much Mark Shannon, but I don't say that. Then Mark Shannon added branches in async for loops are now instrumented, which is like now the tier 2 instrumentator can use them, and then the JIT and everything is happy, and you can have
and Yury is happy
because async for loops that may or may not be using async generators can trigger. Very good. Thank you, everyone. We probably miss half of the PRs that are small, but like they're also important. We also believe that those are important, but you know, this already is close to 2 hours. You don't want to listen to this weird Spaniard for 2 hours. So let's switch to something different.
So now let's talk about free threading changes. So the changes that work against performance, like we're gonna go
the battle of two titans.
But yes, exactly. So now I'm gonna be like this advocate of the devil, where free threading rules the world. We have actually very cool changes there, and I can only cover a few. So let me start with this one, which I was particularly excited about, that now you can run regression tests in parallel threads.
That's insane. That's insane.
Like we should have had this like since day one, but it was very hard to actually get there to this point. So now you can, and we're already doing this for HashLib, and it's already finding problems like quicker than you could otherwise. So yes, like now thanks to Sam, we can run regressions in parallel using threads. So now we will actually stress test the free threading very much. So I love this. There's also like a contributor that we are seeing more and more of, Tomasz Pytel, who made array_module.c and byte array thread safe, and also fixed some data races in like regular expressions, like in compile template and in hash open SSL. And that's one of those things that was discovered by the parallel thread runner. So, you know, everything is
very cool.
Yeah, very cool. And speaking of types, function object dunder annotations also had some data races. So that was fixed by Xuanteng Huang. And we have per thread tasks now using a linked list in asyncio. So the PR of the week that we're talking about had to have like a tiny little bit put in the thread state such that an external interpreter could easily find what the current running task is without parsing Python dictionaries, where from outside of the process, you cannot easily run C API Python code. So actually supporting an entire Python dictionary is very complicated, and it takes a long while. It's complicated. So just having a pointer was worth it, like to just allow external introspection to just go to this one predefined place that we knew was good. And I put this on the thread state, which it turned out luckily was where we wanted to have it in the first place. And Kumar actually realized that, you know what, the easiest way and the best way to solve thread safety issues is to make things thread local. So now we have per thread tasks like in a linked list in asyncio. So like the linked lists are per thread. So that's pretty amazing, and it required Kumar to fix thread safety of PyList set item for it to work.
Right. That's how you scope creep the hell out of everything, and that's how you fix. You have thread safety.
Yeah, so that's very cool.
Yes, he's doing a lot of work on asyncio, and he has also some good ideas for how to improve the asyncio introspection. So we may be hearing about Kumar more in the future.
Right. Yes. Like very impressed by the guy. So we had some crashes that were fixed that were related to usage of PySys underscore get object, which is one of those APIs that we know and hate.
Evil.
Yes, that are returning borrowed references. So now Serhiy Storchaka replaced all of that across the entire code base with APIs that use strong references, removing some of those rare crashes that were very hard to identify where they were coming from. Stack pointers in interpreter frames are, to quote Sam, nearly always valid now.
Yes. Mathematical terms.
Right. So they are now actually used when traversing threads stacks. So that's pretty cool. And Dino, not the Dino that Yury was talking about, but Dino Viehland, our good friend from Meta, made it such that locking is avoided when clearing objects, which is always great. Like when you avoid locking, things that we slowed down for free threading are no longer slower than the regular version.
This is also a big deal because the GC is doing that all the time.
Exactly right. Yeah, and there's a ton of other changes that we will not get to today. So again, sorry for everybody who we actually not.
It was Guka's fault. It was Guka's fault. Oh, it was Guka's.
Yes, because of me, we are at 130 minutes at this point. Yes, that's entirely my fault. I take the blame.
But it's cool. We talk about all asyncio, and I think Yury's battles were super cool. Like most of the feedback we get from people is that they like the kind of insights and whatnot, and that's the background.
But you know what they hate? They hate it when you make a new section of the podcast and you bet with me on a thing, and then we don't resolve it in the next episode.
Well, but this is a special. We didn't forget. This is a guest episode. We have Yury. We are not going to miss time just because I didn't ask Guido about it and like I need to still do it before we. No. It's not about that. It's because we have Yury. We need to focus on Yury.
And that we did.
We will resolve the bet later.
All right. Okay. So I'll edit this out then. But
no, leave it. I'm a proud person. Like I live with my mistakes.
Okay.
Sorry, my decision.
Oh, okay. Yes, like a Freudian slip there. But yeah, but I will accept your excuse. It's a good excuse. In any case, we're very, very fortunate to be able to spend 2 hours with Yury and talk about like Python and non-Python things with him. Every time we see each other in real life, like we spend more and more hours on this sort of thing. So now you have like this tiny sort of sample of what it would be to sit at the same table with us, like at some evening in a conference or course sprint. So yeah, perks of being core devs. Again, anyway, thank you, Yury, for coming to our little podcast and sharing what you're focusing on today and what you're thinking about like Python contributions in the detail and in the sort of, I don't know, bird's eye view. I think this is going to be a very interesting episode to everybody.
Yeah, people are going to love it.
Try Jill today.
Thank you so much for having me. And looking forward to PyCon US and that secret stock.
Yes. Go to PyCon US.
Yes.
And enjoy some fruity talks.
Yes. Talks on Saturday.
Yes. Saturday is going to be a good day.
Yeah.
Yes, so I
What an
hear.
embarrassing day.
Yes. But that's where the real core developers are tested in front of thousands of people. Some interesting trend. Okay, I'm going to push the button that says stop recording. Okay, stop recording.